Okay, so we talked about our three rules. Now we're going to do limits as x goes to infinity. This is essentially your end behavior of your function, or your horizontal asymptote. So we're talking about as x goes to infinity, or goes all the way to the right, what is this graph getting closer and closer to? Well, that's our asymptote. So we can do the same process we did before. So for this one, the limit as x goes to infinity is going to get closer and closer to 1/2, our horizontal asymptote. Now let's do this one. Limit as x goes to negative infinity. So this is as we go to the left. Same process. So we get 5x to the 4th over 10x to the 5th. So that's 1 over 2x. Well, as x is going to negative infinity, really, really, really big negative numbers, so 1 over 2 times negative 1 trillion, that's getting closer and closer to 0. And for this one, 5x to the 4th over 10x cubed, 1/2 x. This one does not have a horizontal asymptote, so the limit as x goes to infinity is going to be going up. So I think about this in terms of plugging a really big number in for x. 1/2 times 1 trillion. It's getting closer and closer to infinity. Or you can just say it does not exist. The limit is not going to exist because it's going to keep getting bigger and bigger and bigger and bigger. Okay, last one. This is a good note. Make sure we consider the highest degree terms, not the highest degree factors. So we need to think about multiplying this out. So if I have 2x times x squared, so this would be the limit as x goes to infinity. We have the highest term there times this x is going to give me a highest term of x squared. The highest term here is x times the highest term I'm going to get there, 9x squared. So that would be 2x cubed over 9x cubed, which would be 2/9. Okay, in the last video, we'll talk about limits of a couple other functions and we'll be done.